One night of poor sleep raises your cortisol, spikes your blood sugar, and temporarily ages your immune system by 10 years. 3 consecutive nights, the biological damage takes weeks to reverse. And after 45, that recovery window gets significantly longer. This is not about feeling tired the next morning. Because here is what most people do not realize. Sleep deprivation after 45 triggers a completely different biological response. Your melatonin production has already declined by up to 50% compared to your 30s. Deep sleep stages are shorter. And your cortisol rhythm, the system that controls fat storage, is now harder to reset overnight. In the next 10 minutes, I am going to walk you through exactly what happens to your body night by night when deep sleep is disrupted after 45. And I will show you the cortisol-first reversal approach designed specifically for your physiology at this stage of life, so you can stop the damage before it compounds. Before we go night by night, understand what has already shifted in your biology by 45. 3 changes that make sleep deprivation far more damaging now than it was at 30. First, slow-wave deep sleep, the most restorative phase, has already declined by up to 50% compared to your early 30s. Second, melatonin output has dropped, weakening your body's internal sleep signal. Third, cortisol clearance has slowed, meaning stress hormones from one bad night linger well into the following day. Most people believe the damage from poor sleep is simply about tiredness. It is not. The real mechanism is hormonal, and it starts within the first 90 minutes of disrupted sleep. When you miss deep sleep, your pituitary gland fails to suppress cortisol the way it should. That cortisol spike then drives blood glucose up even without eating. Insulin rises in response. And your cells already slightly insulin resistant after 45 become more resistant still. So here is what the research now shows broken down, night by night. Starting with the first disrupted night, your body begins a cascade that builds on itself. Each stage compounds the last. The damage is not random. It follows a predictable biological sequence that researchers have now mapped in detail. After 45, that sequence accelerates, and the window to reverse it narrows with each passing night. Here is exactly what happens. Night 1. The cortisol surge. Your cortisol should reach its lowest point between midnight and 2 in the morning. During undisturbed deep sleep, your pituitary gland actively suppresses cortisol output. But when deep sleep is broken, that suppression fails. Cortisol rises and blood glucose rises with it, even without eating. Your liver releases stored glucose in direct response to that cortisol signal. By morning, your fasting blood sugar is measurably elevated before you have touched a single meal. Here is what makes this different after 45. In younger adults, cortisol typically normalizes within a few hours of waking. After 45, cortisol clearance has slowed significantly. That means the elevated cortisol from the night before is still measurable in your bloodstream the following afternoon. You are not recovering between nights you are accumulating. Each bad night adds to the hormonal load of the last. Researchers at UCLA found that even one night of partial sleep restriction activates biological aging markers in blood cells. The same gene expression patterns appear in cells associated with cellular senescence, the first step toward accelerated aging. That is not a metaphor for feeling old. That is a measurable molecular event beginning on night 1. Night 2 and 3. Insulin resistance spikes. By the second night, a new layer of metabolic damage begins. Your cells have been bathed in elevated cortisol for over 36 hours. And now the insulin receptors on your muscle cells, which normally pull glucose out of the bloodstream, begin to downregulate. This is insulin resistance developing in real time. Your blood sugar stays elevated longer after meals. Your pancreas works harder to compensate, and energy storage shifts away from muscle toward fat. Here is what makes this different after 45. Insulin sensitivity in your muscle tissue naturally declines with age, even under ideal conditions. So you are starting from a lower baseline than you were at 30. 2 nights of disrupted sleep can push your glucose regulation into a compromised range. In a younger adult, that same level of impairment would take a full week of poor sleep to produce. After 45, it takes 48 hours. A study published in the journal Diabetes tracked adults restricting sleep to 6 hours per night over 6 weeks. Insulin resistance increased by 14.8% overall. In postmenopausal women specifically, it rose by 20.1%. The researchers noted that hormonal changes after menopause significantly amplify the metabolic damage of sleep restriction. Night 4 through 7. Immune system aging. This is the inflection point the window researchers describe as the biological switch. By the fourth night, immune function begins to show measurable decline. Natural killer cell activity, your body's first defense against damaged and abnormal cells, drops significantly. Studies have recorded reductions of up to 28% after 4 consecutive nights of disrupted sleep. Inflammatory cytokines rise. C-reactive protein, a key marker of systemic inflammation, increases. Your immune system is no longer in maintenance mode. It is in low-level crisis response. Here is what makes this different after 45. Your immune system's baseline is already running hotter at this stage of life. Chronic low-grade inflammation, sometimes called inflammaging, has already begun its slow progression. When sleep-deprived cortisol amplifies that inflammation, you are not adding to zero. You are adding to an already elevated starting point, and the compounding effect is steep. Researchers studying sleep disruption in adults over 45 note that immune aging markers after 4 nights can resemble the immune profile of someone a full decade older. That is not gradual decline. That is acceleration driven by nights you may not even remember as unusually bad. Research examining toll-like receptor activation in adults aged 60 to 84 found that sleep disruption and aging amplify each other's inflammatory effects. The combination produces inflammation greater than either factor alone would generate. Sleep loss at 60 is not the same as sleep loss at 30. The biology has changed, and so has the cost. Week 2 through 3. Cognitive markers begin to shift. By the second and third week of disrupted sleep, changes become visible in cognitive function. Working memory, the ability to hold and manipulate information, shows measurable decline. Reaction time slows. The prefrontal cortex becomes less active during tasks that require focus and decision-making. Emotional regulation weakens. Many people at this stage report increased irritability, poor decisions around food, and a mental fog they cannot quite explain. They attribute it to stress, or age, or being busy. It is the sleep debt compounding. Here is what makes this different after 45. The hippocampus, the brain's memory and learning center, is particularly vulnerable to elevated cortisol. After 45, hippocampal volume naturally begins a slow, age-related decline. Sleep-driven cortisol accelerates that decline during this window. Researchers tracking sleep-deprived adults over 50 have found something striking. 2 to 3 weeks of poor sleep can produce cognitive test scores that resemble patterns seen in early cognitive decline. Not permanent damage, but a preview of a trajectory that becomes permanent if the pattern holds. The American Academy of Sleep Medicine confirmed that partial sleep restriction accelerates biological aging markers in older adults, including markers linked to early neurodegeneration and reduced brain resilience. The research is clear. The brain is not immune to sleep debt. It is uniquely vulnerable to it after 45. Month 1 and beyond. Visceral fat accumulation begins. If the pattern of disrupted sleep continues past 30 days, the consequences become structural. Chronically elevated cortisol drives a specific type of fat storage directly to the visceral region, surrounding your internal organs. This is not subcutaneous fat, the kind you can pinch. This is deep abdominal fat, metabolically active, inflammatory, and far more dangerous to long-term health. The pathway is direct: cortisol up, insulin resistant, fat storage redirected inward. Here is what makes this different after 45. Estrogen decline in women and testosterone decline in men both reduce your body's natural resistance to cortisol-driven fat storage. After 45, you have fewer hormonal buffers against that visceral fat signal, which means the fat accumulates faster and concentrates in more dangerous locations. And here is what makes this particularly difficult to address. Even recovery sleep does not undo it quickly. A study published in the journal Obesity found that experimental sleep restriction caused an 11% increase in visceral fat area. When participants were then given catch-up sleep, visceral fat continued to increase, it did not reverse. The researchers concluded that inadequate sleep is a trigger for visceral fat deposition and that short-term recovery is not enough to undo the accumulation. 1 month of poor sleep is not a temporary setback. It is a structural shift that requires a sustained protocol to address. The reversal protocol does not begin at bedtime. It begins at 2 in the afternoon. By 2 p.m., your cortisol should be descending naturally on its daily curve. Anything that spikes it after that point disrupts your sleep architecture hours later. That means no caffeine after noon, no intense exercise after 3 p.m., and no high-contrast screen exposure after 8 p.m. For adults over 45, shift your workouts to the morning window before 10 a.m. where cortisol works for you, not against you. Research on circadian cortisol timing consistently shows that morning exercise reduces evening cortisol, the exact mechanism that protects deep sleep. Now the sleep environment. Your core body temperature must drop to initiate deep sleep, and after 45, this thermoregulation process becomes less efficient. Set your bedroom between 60 and 67 degrees Fahrenheit, that is 17 to 19 degrees Celsius. This gives your body the external thermal signal it can no longer generate as reliably on its own. And use blackout curtains. Even dim ambient light suppresses melatonin output, and after 45, your melatonin is already reduced by up to 50% compared to earlier decades. You cannot afford further suppression. The final layer is your morning cortisol reset. What you do in the first 30 minutes of waking shapes your cortisol curve for the entire day. And after 45, that curve directly controls your sleep architecture the following night. Get natural light within 10 minutes of waking outdoors if possible, or a 10,000 lux light therapy lamp. Eat a protein-forward breakfast within 60 minutes of waking. And hold off on news, email, and social media until after that light exposure. This sequence anchors your circadian clock, which weakens after 45 and sets cortisol on a healthy descending path that makes deep sleep possible again, night after night. Here is the bigger picture. Every night of deep sleep is not just rest, it is a biological maintenance window. Your brain clears metabolic waste. Your immune system resets. Your cortisol rhythm resets for the next day. Researchers at Harvard Medical School have found that adults who consistently achieve quality sleep show measurably lower rates of cardiovascular disease and cognitive decline past the age of 70. Not slightly lower measurably, significantly lower. Sleep is not a passive state. It is the most powerful longevity lever your body already possesses, and it costs nothing. If this breakdown changed the way you think about sleep, share it with someone who needs to hear it. Because one conversation can change a pattern, and one changed pattern can change a decade. In the next video, I am going to show you the exact fasting window that activates your body's cellular self-cleaning process, a mechanism called autophagy, and why the timing of that window shifts significantly after 45. I will see you there.